This is the second version of what I'm going to call the open channel truck concept. And I'm just going to go ahead and ride right now because it is very cold and windy. So get riding in and then we'll talk about it after. So I've got the penny on the front, penny trucks, because that's what I had. And I set these up with big wheels because I've got a bigger cylinder this time. And I've got it set up on the 2D Plus board. So here we go. You can already see, well, you can see it's getting wheel bite. You can already see it's got a lot more turning action already. Okay, so this is version 2 of the open channel truck concept. And this one actually is working pretty good, unlike the first version, which didn't work at all. So first version was here, and you can see this is the open channel, and it just wasn't retained well enough, and it could flop around and not stay in place. This one, I've made the channel walls taller, and it encloses it a whole lot better. But the whole idea with this concept was as a way to kind of allow eSkate to work in a smaller package for smaller setups, like this guy here. Because I've been developing these mini cruisers. And I've been thinking a little bit like, oh, how could you even set up eSkate on something so small? So that's kind of where it all started in my brain. So you can imagine that, you know, this cylinder here, imagine it with a full cylinder, that would kind of be like the motor can. And the idea would be to have, you know, one motor drive both wheels, and you just build the turning mechanism of the truck. You just build that into the motor itself. And so that's how I ended up with this idea. So, let me talk a little bit about how it works. So a normal channel truck, let's say we're going to have a angle like that, right? So a normal channel truck will have two parallel walls, and it's going to have a bolt going through it like that. And this bolt is the pivot axis. Pivot, and the hanger just goes inside the channel, and it's held in place by both the bolt and the channel walls. And kind of the idea with this is you're just shoving the motor in between the channel walls. It's kind of like the phase 1 of what's going on there. You've just shoved the motor inside and put walls around it, and then you've made it a channel truck. Except I'm not just relying on walls on all sides. I'm not relying on a pin going all the way through. I'm just using a bushing on one side, so it actually ends up changing the geometry a bit. So in this design, what we've got going on is we have the motor cylinder there, and then we have the pivot cup here, and the center of the pivot cup makes up one point that you measure the pivot axis from, and then the other point, so that's kind of what I got here, the other point is actually the bottom of the channel right here, which would be, say, right there. So the channel would go something like that, and that would be the pivot axis, and the channel walls would be perpendicular to this angle here. And that allows us to not have to have this this through axle going on through the through the channel. So we're actually using the bottom face, you know, the very bottom of the channel, as kind of like a pivot cup hybrid channel thing. So it's a really strange mashup of characteristics. One huge side effect of this is that the axle is right here, in line with the motor, and you've got a huge axle offset. So the axle offset ends up being exactly half the diameter of the motor can. So axle offset is okay, but you definitely don't want to get too much of it. So that's definitely one limiting factor with this design. So that's kind of the technical side of how it's working. But let's take a look at the actual truck here. And yeah, so what I've done to this one, basically, in comparison to the first design, was I just made the channel walls taller. There we go. There we go. So, if I line this up for you, there, I think you can pretty clearly see you've got channel walls here, so the inside and outside there, and the angle is perpendicular to the pivot angle. And then here we've got, now this would be a pretty decent sized motor can, and that would, I think, be plenty substantial for a lot of use cases. And of course it wouldn't be, you know, cut out like that. It'd be a full cylinder. And this ends up being just over a 5-inch hanger. And I think you could get this a little narrower, especially if you messed around with other wheel options. So in this version 1 design, I designed in this cam profile. So it would have a raising center of gravity and a motion kind of like an other planet truck would have, right? And because this didn't work almost at all, I basically dropped all the other concepts and I just designed this one to work. And I'm not sure if that's something that could be reintroduced or not to this sort of design, but I think it could be. But yeah, so what this is this just is a circle radius that's swept around, you know, the pivot axis. And basically all I did is I just swept this cylinder around the pivot axis is all I did to create that. And I designed it to have 35 degrees of lean, and so that kind of dictated that these edges right here would be 35 degrees up, and it's also a 35 degree pivot angle, so I just used kind of 35 degrees everywhere. So one other idea I had for this concept was, instead of having this just be a hard rigid surface, to have a polyurethane sleeve that kind of just sits in here and locks in with the base plate, so that your hanger or your motor can is actually sitting and resting on polyurethane to cushion out the ride. And I think there's some chance that doing that could introduce some extra slop in the system and let things move around a little more. But it might be a worthwhile trade-off just to make the ride a little bit more comfortable. So the other thing I wanted to bring up with this was that I think there's a limitation with what angles this is viable for. So, you know, pivot angles. So if you're doing a 0 degree pivot angle truck, then the channel is going to be straight up and down like that, you know, and the board would be flat. And if you do that, then there's a lot more support for the can or the hanger. But as you add more and more and more angle to it, there's just going to end up being less and less support available. And yeah, so I think this is most viable a design for lower angle trucks. And so I think 35, that's a nice angle for a rear truck. And so I think this might be a good design for a rear truck, and might not necessarily be a design you'd want on a front truck. Even though I do think front wheel drive e-skate is probably the way to go instead of rear wheel. Okay, so closing thoughts. Do I think that this is a viable concept for a truck? Probably. I think probably. It's bringing over a couple caveats with it that you'd have to design around, and it couldn't be a one-size-fits-all, for anything. But for a specific use case, I think it could still work. Once I moved away from this design, this didn't work at all, and things were looking kind of crappy for the idea. But this version seems to be working pretty well. Now, as for electromechanically, if it could be, if you could set up a motor to effectively drive a board in this configuration and have it be optimal is another question. But I think just mechanically, just the truck concept, I think it's viable. So there we go. That is the open channel truck concept. Longboard Technology, over and out.